So picking up where we left off, we were talking about ions. We're going to learn how to name ionic compounds. First, we're going to talk about binary ionic compounds. What does the word binary mean? Two. A binary organic ionic compound has two elements in it. Exactly two. You have a metal and a nonmetal. And so when we name these guys, we give the name of the cation first, and then the name of the anion. The name of the anion changes the ending of its name to "ide," and the name of the metal cation is just the name of the element. So I think of metals as being masculine and nonmetals as being feminine. And so the metal always comes first. Why? Because that's the way we do it. When you address a formal invitation, it's always Mr. and Mrs. Why? Because it's convention, right? We just do it, and we understand that nobody really thinks too much about it. So it's the same way here. It's the masculine, the metal first, and then the nonmetal. Now, traditionally, when a woman marries, she changes her last name, right? And so the nonmetal, who in my fantasy world I call chemistry land, this is the female. She's going to change the ending of her name. The metal doesn't change his name. Okay? So let's look at this a little more specifically. Let's look at NaCl. Just looking at the formula, we can tell that this is a binary ionic compound. There's two elements, sodium and chlorine. And the sodium is a metal, and so that's how we know that it's ionic. So what we're going to do to name this is we're going to first name the sodium and then name the chlorine. So the two ions that we have here, we can predict their charges from the periodic table. Sodium has what charge? There's the periodic table. +1. And chlorine has what charge? -1. So to name this, we look at this first element and we ask, well, what's the name of that ion? Well, it's just sodium. Sodium is in group 1A, and so it always forms a +1 ion, and so it doesn't need anything else, and so that's sodium. Okay. The other element is chlorine. She's going to change the ending of her name because now she's in this union, in this compound, right? So we change the ending "ine" to "ide," and so we get chloride. And then we write the two names next to each other. A compound name almost always has two words, just like people go by a first name and a last name, right? And there's a space in between. There are some exceptions. Sodium chloride. Any questions? These are some of the common nonmetal anions. So here's fluorine. This is the ion that it forms, and so the anion name is fluoride. Bromine becomes bromide. Oxygen. Okay, we're not just taking off the last symbol. That would be oxygide. That sounds kind of funny, right? I don't know how they decided these things. Oxygen becomes oxide. Sulfur becomes sulfide. Nitrogen becomes nitride. Okay? So at first they'll be a little bit strange, but there's not that many of them, and you get used to them after a while. So name this compound. KBr. Well, what are the two elements involved? You've got potassium and bromine, right? So we've got potassium ion and we have bromine ion. We're going to name the metal first. Potassium is in group 1A, so his name is just his name. Potassium. And then bromine changes the ending of her name. Bromide. Potassium bromide. These are not proper nouns, so we don't capitalize them. And spelling, sadly, for some people, matters. Because the difference in spelling between bromine and bromide is one letter, isn't it? If you write potassium bromine, I think you're talking about two separate elements. So we have to change the ending of the name there. Any questions? Let's look at this one. Zinc and nitrogen. Right? So zinc. I didn't show, there wasn't a periodic table. I was expecting there to be one in the notes, and there wasn't. If you look over here on this periodic table, here's aluminum in group 3A, right? So he's +3. And then I imagine coming down the stairs. You go to the left and down one step is zinc. What's one less than +3? +2. And you go down one more step, and silver is +1. So aluminum's +3, and then you can just go down the stairs to the left, zinc and silver. So zinc is always 2+, just because I told you. But there's no other good reason I can give you right now. Nitrogen forms what kind of an ion? What charge? -3. We're going to count backwards on the periodic table. Neon 0, fluorine's -1, oxygen's -2, and nitrogen's -3. So this is one of those guys that only forms one ion. And those groups are 1A, 2A, 3A, zinc, and silver. And you just have to remember that. If it's in one of those groups, the name of the cation is just the element name. So that's zinc. And what does nitrogen become? Nitride. So this is zinc nitride. Okay? And what your book calls type 2 binary ionic compound, here the metal ion can be different charges. And so we use a Roman numeral to specify what the charge is. So this is a little bit like what humans do, right? I was just listening to Mark Twain's The Prince and the Pauper, right? And there's King Henry VIII. Why does he have the Roman numeral 8 after him, after his name? Because he was the 8th one with the same name, right? And so, you can have John Smith Jr., John Smith III, John Smith IV, John Smith V, right? It's how many there have been. And so we use Roman numerals on these elements as well to tell what the charge is on the ion. What's next here? Okay, so here's an example. Copper, find it on the periodic table. It's in the middle, isn't it? It is not in group 1A, 2A, 3A, zinc, or silver. That means it can form more than one ion. These are the two ions that it forms, a +1 and a +2. You can't really get that off the periodic table. So in the name, then, we have to specify the charge. And this is like copper the first and copper the second. Okay, this is copper with a +1 charge and copper with a +2 charge. Let's just review our Roman numerals real quick. Capital I is 1. 2 capital I's is 2. 3 capital I's is 3. Now, if you just went on like this, it would get really tedious to write 1,573,000, wouldn't it? Well, 5 is V. Don't ask me why, because I don't know. 4 is 1 before 5. 1 less than 5. And 6 is 1 more than 5. Aren't you glad you don't have to do math with Roman numerals? How do you multiply and divide those? Anyway, we probably won't get past 6. But this is copper 2. The Roman numeral is the charge. The Roman numeral is the charge. So for this type of compound, we've got the name of the cation. The man still comes first, the masculine. Now in Roman numerals, we've got, in parentheses, we have the Roman numerals telling us the charge, and then we're naming the anion in the same way. So we're just adding something in the middle. How do you know what the charge is on the ion? You have to figure it out. You figure it out from the formula. So if we look at this example, FeCl3, if we're going to go to name that, we find iron on the periodic table. We ask ourselves, is it in groups 1A, 2A, 3A, zinc or silver? Is it? I really need a laser pointer. Fe, right here. Is that in groups 1A, 2A, 3A, zinc or silver? No, it isn't. That means we need to put a Roman numeral in the name. We have to figure out what the charge is. So this is kind of backwards of what we were doing with writing the formulas. So we've got iron and we've got chlorine. Those are the two elements. We don't know what the charge is on the iron, but we do know what the charge is on the chlorine. What charge does a chloride ion have? -1, right? So then we have a little puzzle here. We have to figure out what the charge is on the iron. How many chlorides are in the formula? I don't know where I'm pointing. There are 3. I'm going to just draw 3 of them here. So that's a total negative charge of -3, right? The positive charge and the negative charge have to be equal, so they add up to 0. So that means over here I need a +3 charge. How many iron atoms are in the formula? What's the subscript? It's an implied 1. There's only one of those guys, right? So he must have all of the charge. He must be a 3+. Because then the charges work out. Does that make sense? So we figure out what the charge is. Now we can name him. That's iron. And we put the charge in Roman numerals in parentheses afterwards. There's no space between the end of the element name and the parentheses. Just Word doesn't like that. It yells at me all the time, but that's how chemists do it. And then there's a space, and chlorine is chloride. So that compound is iron 3 chloride. No, I already did that. Skip that. Okay, let's name a couple other ones, because you're going to need to do this on the worksheet. So here we've got PbO. The first thing to do is find that first element on the periodic table. Do you see it? Is lead? It's over here towards the right. Is it in groups 1A, 2A, 3A, zinc or silver? No. It's actually in group 4A, isn't it? But it's not in the ones that we list, and so it needs a Roman numeral. So then we're going to look at this, and we've got 1 lead ion, and we have 1 oxygen ion. We don't know what the charge is on the lead, but we can figure out the charge on the oxygen from the periodic table. What is it? 2-. This one's easier than the previous example because we just have 1 of each. So if the oxygen's -2, the lead must be +2. Okay, so then writing the name, we name the first one first, lead. It has a 2+ charge, so we put the Roman numeral 2 and leave a little space, and we change oxygen's name to oxide. This is lead 2 oxide. Let's do this next one, Cu2S. Well, write the two elements. There's Cu and there's S. Find Cu on the periodic table. It's a metal, right? Is it in groups 1A, 2A, 3A, zinc, or silver? No. I'm going to say that list so many times this morning that you're going to have it memorized before you leave. That's my goal. 1A, 2A, 3A, zinc, or silver. It's not that hard. So we don't know what the charge is on the copper, but we can figure out the charge on the sulfur. What is it? It's 2 minus. And we see from this that we have 2 copper ions. So let's write both of those in so that we have everybody represented. This is not the only way to figure it out, but most students seem to like it okay. So what's my total negative charge? Minus 2. And that means my total positive charge has to be plus 2. Right? Because it has to balance out to be 0. Well, I've got a total of plus 2 charge, and I need to divide it between these guys equally, so they're each going to be what? Plus 1. So some of you have a math phobia. You think you can't do math, and you look at stuff like this and you go, ah! At least in your mind you do. But this is the same as thinking about, okay, there's this little meeting or a little party or something, and here's one mom, and she's bringing 2 cookies. So there are a total of 2 cookies. And these are the little boys, they're masculine. There are 2 cookies, and we need to share them among the boys equally. How many cookies does each child get? 1. I have yet to meet a Chem 20 student who could not do a problem like that. When it's cookies and children, you can do math. You understand the math. You just freak out a little bit when I start talking about charges and elements and ions. Okay, so just remember, don't make it harder than it is. So we figured out the charge, it's plus 1. So Cu is copper, so we write copper, and in parentheses the Roman numeral 1, and sulfur becomes sulfide. Any questions? So those were binary ionic compounds. We also kind of mentioned polyatomic ions. There are polyatomic ions that have more than one atom in them. And the names of these just plain have to be memorized. The names of polyatomic ions must be memorized. Now, you, in the course of your life, have memorized things much more complicated and difficult than this. Some of you guys can probably spout off a whole bunch of sports statistics, right? And women tend to talk about other things, but like for me, I can tell you the weight and length and birthday and birth time of each of my 6 children. How do I remember all that? Well, it's kind of important to me. So if you make something important to yourself, you can remember it. So these things you just have to memorize. Here they are. These are the ones you need to memorize. There are some patterns in here. You'll see that most of these polyatomic ions have oxygen in them. There's very few exceptions. Most of them have oxygen, and the oxygen usually goes last. There's one weirdo in here that has a positive charge. Can you find him? Ammonium. Okay, that is the only polyatomic cation that we will run into in this class. So that one's kind of weird. Let's look at nitrate. Nitrate is nitrogen and some oxygens with a negative charge. Chromate is chromium and oxygens with some negative charge. And sulfate is sulfur and oxygens with a negative charge. Okay, so they've got something in common. There's, this guy is a little weird. Cyanide and peroxide. Those don't quite fit the pattern. And then there's hydroxide. So those guys are a little bit weird. Those ions that have oxygen in them are called oxyanions. They're anions with oxygen, oxyanions. And they form series. There's sulfate and sulfite. There's nitrate and nitrite. And the difference is in the one letter in the suffix of the name. And there is a systematic pattern to that. And let's look at these. Nitrate, nitrite. They have the same charge. They have the same number of nitrogens. The only thing that's different is the number of oxygens. So the charge stays the same. The other element stays the same. The number of oxygens is the only thing that changes. I think I've got a slide. Yeah. So this isn't set up the best way, but we'll deal with it. So you memorize the one that ends in 8, and then you can figure out the others from this pattern. One fewer oxygens has the ite. Okay, what's the difference between Bud and Bud Light? Bud Light has a third fewer calories. We've all seen the commercials, right? Nitrite is like the light version of nitrate. It's got fewer oxygens. One fewer oxygen. So here's nitrate. Nitrite is the light version, one less. Here's sulfate, has 4 oxygens. Sulfite is the light version. Okay, so you memorize the 8, and you remember that the ite is the light version. When there are more than 2 in the series, and for some there are, then we're going to stick some prefixes in here. Hypo and per. So hypo means less than or below. Where does a hypodermic needle go? It goes below your skin. Hypodermic. Your skin is your dermis, right? So hypodermic literally means below the skin. So hypo is one less than the light version. So here's chlorite. There's chlorate. That's the one you memorize. ClO3 with a negative charge. Chlorite has 1 less, and hypochlorite has even 1 fewer. And then per comes from hyper. It means more. Someone who's hyperactive is more active, right? So hyper means more. So we've got chlorate. Perchlorate has 1 more oxygen. So there's this pattern. And just a note about mastering chemistry. When you're naming these in the homework, mastering chemistry wants you to include the word ion. So if it says name this and you type perchlorate, it's not going to be happy. We want mastering chemistry to be happy because he gives us more points that way. So you need to write perchlorate ion. Technically, that is correct, and I'm not going to get hung up on it. But mastering chemistry is definitely hung up on it. Here's some examples of these polyatomic ions. You run into them on pretty much a daily basis. Sodium hypochlorite is the active ingredient in household bleach. It kills stuff and destroys colored compounds, and so it makes your clothes whiter. Sodium bicarbonate. Bicarbonate is a polyatomic ion. That's the active ingredient in baking soda. And when you bake and you mix that with something that's slightly acidic, it gives off carbon dioxide gas, which causes the food to puff up. That's why biscuits are puffy without having yeast in them. Calcium carbonate. This is one of those polyatomic ions. That's found in antacids. It neutralizes your stomach acid that's causing your heartburn. Sodium nitrite is a preservative for packaged meats. Now, is it good for you? No. But it inhibits the growth of botulism. Is botulism good for you? No. I would rather eat nitrites than get botulism. That's just my personal opinion. Okay, so let's name some compounds containing polyatomic ions. So we look at this guy and we think, wow, there's a lot of letters and numbers and stuff in there. Ionic compounds have 2 ions, only 2. So you break this big mess into 2 pieces, and you name the first one and you name the second one. So I look at this and I find the first element. The first element is Mn, and then I'm going to draw a line. That's not my marker. I'm going to draw a line right here, separating those. Those are my 2 ions. Sometimes people want to separate the nitrogen and the oxygen and get all creative. Nomenclature is not a place to be creative. This is not creative writing. This is following the rules writing. You can be creative in other places. So we have Mn, and we have the rest of that. Now, this is one of those bundle packs I was telling you about. Polyatomic ion NO2, and the parentheses tell us that there's 2 of them. I don't need to worry about that right now. This is the polyatomic ion NO2. 2 ions. Only break it into 2 pieces. It's like marriage is 2 people. You know, they're altering the definition, but it's still just 2 people, right? They haven't gone to, oh, let's have 3 or 4 people get married, right? So 2. Okay, now we're going to look for manganese in the periodic table. Is it in groups 1A, 2A, 3A, zinc, or silver? You have to look at the periodic table to answer that. No, it's not. What does that mean? It means that manganese can form more than 1 ion. We're going to have to figure out what the charge is, and we're going to have to use a Roman numeral. So that's going to need a Roman numeral. This guy, what's his name? Well, you haven't memorized those yet. So how do you figure it out? You go look at the chart. Go look at the table. There's the table. We're looking for NO2. So we find it right here. NO2, it has a -1 charge, and its name is nitrite. We need that charge. So this is -1. I'm going to rough out the name here. Mn is the symbol for what? Manganese. Not magnesium. And there's no such thing as manganesium. Well, let's just cover the bases. Manganese. And it's going to need a Roman numeral, so I'm going to put the parentheses in there and leave some space so I don't forget to come back and do that. And then this guy's name was nitrite. So it's manganese something nitrite. Well, let's see if we can do this without drawing pictures. How many nitrite ions are there? 2. So the total negative charge is 2-. That means the positive charge has to be 2+. How many positive ions are there in this formula? Just the manganese, right? Just the 1 manganese. So that must be +2, right? So we give this the Roman numeral 2.
Does that crisscross the word?
The crisscross, a reverse crisscross works sometimes. I don't necessarily recommend it, but it would be better than wild guessing, right? So name this compound. That looks like cocoa 3, but so this first element, CO, that's a metal. And so this is going to be an ionic compound. There's the CO, and then there's everything else. So we've got CO, and we've got CO3. Only 2 pieces. 1 cut. Okay, where is cobalt? Is it in group 1A, 2A, 3A, zinc, or silver? Nope. It needs a Roman numeral. So the name here is going to be cobalt, parentheses, something. And then this guy. What's your best guess for his name? It's a her, really, her name. What would be a guess? How about carbonate? Most of these polyatomic oxyanions take the other element name with the oxygen. This is carbon, and then there's ate or ite on the end, right? There was nitrate, nitrite. So we could guess carbonate or carbonite, and we'd at least be in the ballpark. Well, we could go back and look at the table, but I don't feel like doing it. So I'm just going to tell you, that is carbonate. You can look it up and check that. And carbonate has a 2- charge, because we looked it up in the table or we memorized it. Looking at this formula, we have 1 cobalt ion and 1 carbonate ion. The carbonate ion is -2, so the cobalt ion has to be +2. And if my explanation of all this charge business is not making sense to you, please ask me repeatedly, if necessary, until I come up with an explanation that makes sense to you. I love the challenge. I have one explanation with bowling balls and boxes, so you might just want to hear about that one just because. How can you turn ions and charges into bowling balls and boxes? Oh, it's not that hard. Cobalt 2 carbonate. Any questions? That's where we were, and this is the next section.